Hello everyone, this is lecture 2, set operations. In this lecture, we're going to focus on different operations for sets, including union, intersections, difference, disjoints, complements, and Cartesian product. The motivation for this lecture is that two or more sets can be combined in many different ways. For instance, starting with a set of mathematics major at Bridgewater State University and a set of computer science major at Bridgewater State University, we can form the set of students who are math major or computer science major, or you can find a set of students who double major in both mathematics and computer science, or you can find a set of all students that are not majoring in mathematics, so on and so forth. Before we dive into the first two set operations, union and intersections, I want to introduce to you Venn diagram, because sometimes it's a lot easier to describe the set operations in terms of diagram. So Venn diagrams used to indicate the relationship between set. To illustrate the Venn diagram, sometimes we start with the rectangular box like this. And inside this rectangle, you can draw circles to indicate the set that you want to work with. In this case, I'm just going to use one circle inside. And the rectangle usually is used to indicate something called the universal set. And it's indicated as curly U. And the circle is the set that you're working with. And I call this set A. So U is the universal set, or the set contains all objects being considered. Alright, when we talk about set operations, including union, intersection, so on and so forth, not only we can think about definitions of the operations, the notations that we can use to perform the calculations, but also use the Venn diagrams to illustrate the point that we're trying to make. So the first set operations I want to introduce is called union. So the union is the set of all elements in either A or B or both. The notations that we use is that if I have two sets, set A and set B, I'm going to use this notations A union with B. For the set builder notations, you have A union with B is written as the set of all element X such that X is an element of A or X is an element of B. Now for Venn diagram, again, I'm going to start out with a rectangle to indicate the universal set. Now for set A and set B, I use circle. So this is A and this is B. So by definitions, the union is a set of all elements in either A or B. To visualize the union set operations is to shade the area for the set A and shade the area for the set B to indicate that we want to include all elements in either A or B. So this is going to be A union with B. Now for example, if I have a two set A is equal to the set of the element of 1, 3, 5, and B is the set of the element 1, 2, 3. Now you want to find the union of this two set. What you can do is you write A union with B is the set of, so here the element 1 is in A and it's also in B, so you count at 1. So the next number, let's say 2, in this particular order of 1, 2, 3, so on and so forth. So 2 is in B, so you count that into the union set. 3 is both in A and in B, so you count that toward the union set. And the last item here is 5. 5 is in A, so you count that toward the union set. So in this case, A union with B is the set consists of 4 elements, 1, 2, 3, and 5. For Venn diagram, we can visualize this as follow. So this is the universal set. You have two sets, set A and set B. So in set A consists of the element of 1, 3, 5. Set B consists of the element of 1, 2, and 3. The elements that are both in the two sets are going to be 1 and 3. So this is set A, this is set B. We can show the elements as follows. So this is 5 only in set A. Number 2 only in set B, but 1 and 3 are in both set A and set B, and using the union, we're going to include all of these numbers in the union set. So another example is that I have a set A of all the English vowel, including A, E, I, O, U, and the set B consists of the elements of A, B, C, D, E. Now the union set of A and B is going to be, so A is in the set A, and A also in the set B, so you count toward the union set. Now I'm going to put everything in this particular order of the alphabetical table. So the next letter should be B. B is in the set B. C is also in the set B. D. E is in both A and B, so you can just count one. The next one should be I, O, and U. So this is the union set between A and B. For a Venn diagram, you're going to start again with the universal set. And the two sets, set A and set B. So you can see the common letters in both set A and set B is going to be A and E. So I'm going to start with that. So A is in both set A and set B. And A and E are both in set A and set B. And this regions where I draw A and E is going to be later called as intersection, which is the area where you can find the elements in both set A and set B. Now go back to our example. Set A also consists of letter I, letter O, letter U, and in set B consists of letter B, letter C, and letter D. And you want to include all of this letter in the union set. Alright, so that is the concept of the union set. Alright, we're going to move on to intersection between two sets. So the intersection is the set of all elements in both A and B. The notation for this is A intersect with B. So this the notation here is the upside down U. For the set builder notations, we have the set, so A intersect with B is equal to the set of all the element X, such that X is an element of A and X is the element of B. In terms of the Venn diagram, you again start with the universal set. You have the two sets, set A and set B, and you want only the intersections or the common area between set A and set B, and this area right here is the common area, and that area can be shown as the intersection between two sets, set A and set B. Now let's go back to the previous two example, and we're going to find the intersection between two sets. So the example that we have is that we have two sets. Set A is the set consists of the element of 1, 3, 5. And set B is going to be the set of the element 1, 2, and 3. Now, in terms of the intersection between two sets, it's always good to start with the Venn diagram. So you start out with the universal set. You have two sets, set A and set B. You have the common element in both A and B are 1 and 3. So you draw, this is 1, this is 3. In A, element 5 is only in A and element 2 is only in B. Therefore, you illustrate the result of A intersect with B as follow. This is the set of only two elements, 1 and 3. Similarly, when you go back to the example of the set of all the English vowel A, E, I, O, U, and the set B is the set of the element A, B, C, D, and E. You can see from here that the two elements that are common in both set A and set B are A and E. So you can answer the questions as follow. The intersection between A and B is letter A and letter E. And the Venn diagram of this is that we only going to take the intersection part of the two set. Now that's it for the union and intersections set operations. In the next video, I'm going to talk about disjoint between two sets and difference between two sets.